Hi, I'm Kian, and in this video I'm going to show you how to solve this challenging integral. I got this problem from one of my subscribers named Derek, so thank you. And here we go. So we have the integral of sine inverse of square root of x, and we have to solve. So first of all, I can see that the inside isn't that nice because we have the sine inverse, the square root of x, so maybe I can do a u substitution. So if we let u to be equal to square root of x, and then as a result, if you differentiate, du becomes 1 over 2 square root of x dx. And so when we change the integral in terms of u, we get the integral, and then this 2 square root of x gets multiplied, so we get 2 root x. But root x is u, so we have 2u here, and then we have the inverse sign of u. This is my better representation of the same integral. Now what we can do is that we can't do any u substitution anymore because it doesn't make sense. You have inverse sine and 2u, which aren't really related. But what we can do is integration by parts. So how I'm going to use the DI method or the tabular method. So I'm going to choose something, one part of the function to differentiate and one part to integrate. So I'm going to, since we can't integrate sine inverse of u, that also requires integration by parts itself. And this gets plus minus because the sign changes. So I'm going to integrate 2u, and I'm going to differentiate sine inverse. Sine inverse of u. If I differentiate that, this becomes 1 over the square root of 1 minus u squared. And integrating 2u becomes u squared itself. So what our answer becomes is it becomes u squared times inverse sine of u and then minus this integral, the integral of u squared over the square root of 1 minus u squared du. So we see that this integral can't be done with u substitution, because if we let u to be equal to inside here, this becomes negative 2u, which doesn't really make sense. But we can use trig substitution. So what I mean, we can let u to be equal to sine of theta. And so if we do that for this integral, this becomes the integral of sine squared theta and then the bottom becomes square root of 1 minus sine squared, which is basically square root of cosine squared or cosine, and then we have to multiply by du, so the cosines cancel out. So what we have is basically the integral of sine squared theta, d theta. So what we have, because I don't have much space here, actually I have, I can scroll down. So what I can do is that I can use a trig identity that we know. So I can use a double angle, or not double angle, I'm sorry. We can use a trig identity of, or it is double angle, of cosine of 2x. So we know that cosine of 2x is equal to cosine squared x minus sine squared x. Or we can write it as, basically, cosine of 2x as 1 minus 2 sine squared theta, which I'm going to write here. So we can write cosine of 2 theta as 1 minus 2 and then sine squared theta. And so if we add 2 sine squared theta, subtract this and divide, we can see that this is basically the integral of 1 minus cosine of 2 theta and then all over 2 d theta. And this is equal to 1/2 theta if you split the fraction, if you do the integral. And then by a simple u substitution, that becomes negative 1/4 sine of 2 theta, which I'm going to write the sine of 2 theta as 2 sine theta cosine theta. And I'm going to explain why, because we have to substitute it back again. 2 sine theta cosine theta. Okay, now we have our answer, but we have to plug it back in. So we have our first part of the answer, the square root, the u squared. So we know that u, coming back from here, we know that u is equal to square root of x. So if we square root of x, we basically get x times inverse sine of u, which is square root of x. And then we get minus times this, so we get minus 1/2 theta. If sine theta is equal to u, theta is inverse sine of u. So we basically get negative 1/2 inverse sine of u, or negative 1/2 inverse sine of square root of x. Negative 1/2 inverse sine of square root of x. And then this negative also gets distributed here, so this negative 1/2, and then sorry, not this negative 1/2, and this negative gets also distributed to this negative right here. So what we get is plus and then 1/2 sine theta cosine theta. So we have the plus and then 1/2. And then, since we know that sine theta is equal to u, and u is square root of x, so basically we have 1/2 square root of x, but we don't have any expression for cosine of theta. We know that sine theta is equal to u. So if we, I'm going to do it right here. If you draw a quick right triangle, let's say this is theta. So we know that sine theta is equal to u over 1. So this is u, this is 1. So we know that this side here is by using Pythagorean theorem, we get square root of 1 minus u squared. So cosine of theta is basically the square root of 1 minus u squared over 1, which is itself. And plug in square root of x back in, we get minus, there's a square root of 1 minus x. And then this plus c is our final answer. Thanks for watching. I hope you enjoyed this fun and interesting integral. If you want more videos, please let me know by email and subscribe. Thank you.